We'll go into presentation mode. Nope. Anybody ever use presentation mode on Google Slides? Screen. All right, I'll just leave the slides up. Can everybody see that? Let me take the lights down a little bit. Just trying to figure out. Just a little bit? Okay. Yeah, I got some codes. I was trying to keep the contrast pretty high. How's that? Let's go. All right, so if you're here, you're probably meant to be here because otherwise you would not know to be here. So we skip the part about leaving and not make me feel bad if you're in the wrong session. So these presentations, the slides, which you probably don't need to follow along with, but there are some notes in the end if you care about it. I made a bit.ly link if you want to get to them. Anyone can view these slides with that link. And I also have the link on the last slide, so don't worry about writing it down now. I'll have this last slide up during the last 5 minutes or so. All right, so today I will be giving a pretty high-level introduction to Elixir and Phoenix. The goal being to sort of give you a taste of it and maybe to give you an, some desire to maybe look at it yourself. And I'm going to be kind of giving it, again, like a little high overview and then trying to dive too deep, but I decided just to do a little example app. And learning from my talk last year, instead of coming up with my own example, I'm just going to be going over the Hello World example that's at phoenixframework.org, and there'll be a link to that at the end. So that way, if if I don't cover it correctly, or you are more interested in it, you might, and are not available, then you can just go online and look at the example. And again, the slides are there. Hopefully that font everybody can see. All right, I just kind of covered this. So what I'm not going to be doing is diving into the syntax, because we really basically don't have time for that today. I will be showing in the example app some of the syntax. We'll probably go over a little bit, and if you have questions, that's going to be towards the end of it. I can kind of go over that. Also really won't be learning how programs are structured. Again, we don't have time, but it's pretty interesting in that Elixir inherits from a much older Erlang OTP system, which we'll be getting into, which sort of structures applications both at the code level and how the runtime environment in a way that, especially in Erlang's kind of methodology, the idea is to fail fast. So things are just meant to be break. Code is always assumed to be in the happy path, and the unhappy path is just to explode, and then Erlang restarts you. So that's the idea of not basically worrying about programming about errors. Errors happen, just give up. Everything blows up, it magically gets restarted, and this pretty cool supervision tree. And the last thing is basically I'm not here as some advocate or thinking this is the best thing in the world. It's not a silver bullet. It's a great tool for the right kind of problems you have, which if you really need sort of highly available server apps. And if you've done things like that with other technologies where you end up, along with, if you have a web server, you end up having to have these sort of background processes running. In Rails, you would do it with delayed job or something like that, or you'd use, I forgot the name of it, Cucumber or whatever it is in the Python world. Not Cucumber, Rails. It's another vegetable. The nice thing about that in the Elixir world, those can all run under one umbrella application. So you run the application. The web part is just one kind of small part on that supervision tree. You can have other applications running, all talking the same data, and actually all talking to each other, and distributed not only across CPUs and cores on the same machine, but distributed across a cluster of machines, all transparently. And they're built to do that, so that, again, they kind of fail fast. If you have network partitions, things just blow up, and it restarts itself. So it's in the beginning, you kind of design these for ideas of things will blow up. Sometimes you won't be able to talk to things and that kind of stuff. So what is Elixir and Phoenix? So Elixir is the language. And Elixir Phoenix is sort of, if you're used to Ruby and Rails. Elixir is the language, like Ruby's the language, Rails is the web application framework, and Phoenix is Elixir's sort of main popular web application framework. Let's go over this real quick, and I'll kind of go into the first line to really dive in a little bit about what makes Elixir a little bit different. It is a general purpose language, so it's not like a text processing language like awk or sed or something like that. You use it really for anything. That being said, actually, Erlang and Elixir, one of the things you probably don't want to use it for is text processing because it basically processes text as a list. You have to walk down the characters and stuff like that. So doing like huge, you wouldn't want to do things you would do in Perl. A lot of you're taking gigabytes of text and transforming it. You wouldn't want to do that in Elixir. But again, I said before, if you need some highly available server app, you would do that, and hopefully not pick Perl anymore. It's a pretty new language. So it was created by this guy named Jose Balim. He's Brazilian. I believe he lives in Poland now. He is like partners in I think it's platform Temic. Got some Polish characters in it. I'm not quite sure how to pronounce it. So he started in 2011. First commit is the README, so nothing's really here right now. V1 came out in 2014, and the latest release is 1.6, which just came out a couple months ago. Like I said, it's a pretty new language, but the nice part is it's a new language built upon the Erlang virtual machine, Beam, which is over 20 years old. And along with being on the VM, it actually uses sort of, because Beam was built for Erlang, in the end, it's sort of exactly like Erlang. It's just kind of a different flavor of syntax on top of it. Plus some other things we'll talk about, like metaprogramming that makes programs much tighter. So it's, if you're thinking about looking at adopting, it's not like this that they're trying to reinvent the world again. So they're working on top of something that's been in production with Erlang. Ericsson, the telephony company, built it. And it's pretty famous, having 99.999% uptime. They've had telephone apps or switches up that are up for years that have never gone down. And it's built to do things like hot code reloading, so you can actually change the software out while it's still running. And Elixir actually supports that same thing too. You can do that in Phoenix if you want. You have to do a little bit more work. A lot of people just don't worry about that. They just restart the world again because it takes so quick to restart. And actually, if you were just in Joken's talk, it's comparable to Clojure, to Scala, in that it's sort of a new language, but it compiles down to a kind of existing virtual machine. So you get all that, and just like Clojure, Scala, you can actually escape out of Elixir pretty quickly and use Erlang libraries that are 15, 20 years old. It's just like you can do in Clojure, calling directly to Java methods. So some of the things that makes Elixir different, and I put in the but not unique because I'm not like, oh, this is so great, nobody else does like this. Elixir is actually, you can kind of think of Elixir as when he designed it, he sort of picked things from different languages he liked. The main reason that he actually started working on this, he was a Rails core contributor and got sick of having to deal with Rails, trying to scale Rails apps up. And we get to this, I'm looking at this person here because we worked together on a legacy Rails app that is how many years old? 8?
I think it's 10.
10 years old now. That does not age well. So that's where it's sort of, if you can think of his brain, his mindset coming at this. So some of the things, again, not unique. All data is immutable, just like in Clojure, meaning that you only set it once. But there is syntax in that, unlike sort of a Lispy language, it looks like you can say A equals 1, A equals 2. In the background, actually, what Elixir is doing is creating two atoms called A and A1 and assigning those. So A still, the first one still has its value. And there's a little bit of syntax to actually back reference an existing value if you want to do an equality check. Because of again, with Elixir and with Erlang, the main thing is you see this equal sign, and it looks like an assignment, but it's not. Equal in Elixir and Erlang means equivalent. It's a binding operator. So you can say, in Erlang it would be uppercase A equals 1. That's true, because A is a variable. Anything in uppercase in Erlang is a variable. But then if you say uppercase A equals 3, it's going to blow up, fail. That's not true. That variable that you can only set once in Erlang, and again in Elixir, is forever equal to 1. So you can't reset it. In Erlang you can. You could say equals 3, because in the back end it's actually saying A1 equals 3. And this may seem a little bit weird, but you get used to it, and actually makes the code, compared to writing in Erlang, it makes it much nicer, because it takes some functional, it's basic, really functional language, but kind of gives a little bit of imperative to it, so that you don't have to kind of come with gymnastics if you want to change a variable, and have to kind of think in a functional way that way. So with the design of it is a functional language, like I said, meaning that, and because of that, data is the central focus and not objects. There's no object system with methods that you're passing around and stuff like that. That will, I'm sure with Clojure, that sort of changes your mindset when you're programming in a functional way. You start thinking about, instead of objects moving around, you're thinking about these pieces of data. And in Elixir, you can tag data with structures, and there's ways to match that. So there's sort of you can kind of think of it as objects and methods, because when you pass in, we'll see a little, actually I don't think there's an example in here. In methods, you can give in a pattern match to match this data to a structure, and then to do dispatch on it, be able to run a function based just on that type. But the nice part about that is, though, is Elixir has a large set of built-in, sort of the standard libraries you see in any functional language, list processing, that kind of stuff. And once you get into that, you realize programs get much smaller, because you don't have to write that boilerplate of looping over things and stuff like that. And then it's written correctly, it runs, right? You just use the library method to do that. Once you, again, it's a little bit of a mindset change to do, but once you do it, personally, I think programs get a lot easier to both write and to reason about, because again, you can only assign a variable once. I just put some random things in here. It has this kind of this pipeline operator, which actually I think Clojure has in a library. All that does is a little bit of syntax sugar, that it takes whatever you pass into the pipeline operator gets passed to the next function as the first variable. So you can basically think of pipelines. You can expand out. Imagine you have an inner function bar that has a value that gets passed to foo, right? So in a traditional language, you would either assign bar to a variable and then pass the variable to foo, or you'd put bar inside of an invocation of foo. In Elixir, you would just put foo pipeline bar. So then that basically moves the data along left to right, which seems like a little kind of a silly little bit of a syntax sugar, but it makes programs much more readable, because you can just sort of, if you read English at least, scan left to right. And sort of understand, instead of having, no offense to Clojure, having to go inside out, like figuring out how this thing bubbles up and what the value is at the very end. Again, I know in Clojure, I forgot the name of it. It has a thing to do that, right, to turn it around. Yeah. And then Elixir, another thing that's sort of unique, and again, this is part of Erlang's model, that sort of one of the fundamental building blocks of a program is a process, which is a very lightweight thread. You didn't think of it as an operating system process. It's not really heavy. It's very tiny. And it's sort of the fundamental building block of something, of an application. Inside processes can communicate each other with messages back and forth, and all state stays within the process. So what that basically means is Elixir can schedule processes on this core or this core, or this process could live on a different node in a different machine. And you've designed this program so that messages are passing, and you know in fact that process may not be there when you send the message, because of the way process design is. So you take advantage of that. So that way, when you do have network partitions and things like that, it's handled in your program. You don't have to have special cases for it. It's sort of like how you design programs. And again, I'm kind of giving a lot of hand-warming stuff, hand-waving stuff. Like I said, we don't have a lot of time to get in the deep part of stuff. Hopefully, some of the code at the end, although there's no process stuff in that, we'll show you some of the syntax of Elixir and what it's kind of nice for. And then, yeah, the final thing is data is located in each process, which is really nice in that the GC, the garbage collector, is hyper-local, unlike Python, which has a global lock, which is a lock of the whole world. And most processes live really shortly, so the garbage collector is really, I don't garbage collect, I just forget about it. So there's very fast. To give you an example, like you may have an app, especially if you have like a web app or something like that, you may have 10, 20, 30,000 processes running just on a single machine. Not a big machine, simple machine. And you can write a one line of code to generate 10,000 processes, and it goes insanely quick. So again, Beam is built to do that, the VM. So we're not really, the internal VM is built to do and to work with that. Great, so again, Elixir is the language, so Phoenix is the web app. It's Rails inspired. It wasn't actually done by Jose, even though he was a Rails core guy. It was done this guy, Chris McCord. And it is sort of Rails inspired in that it uses sort of the same thing Rails has. It has some strong ideas of how structure of the application should be. What's the Rails saying, configuration over, or convention over configuration or something. And it was started in 2004, and the current release is 1.3, and 1.4 I think is in like beta, like almost ready to hit. Unlike Rails, Phoenix is a collection of composed modules that are available to any Elixir app. So in Rails, you have things, you have this one Rails gem that has active record for the model, active action view for the view, and an application controller for the controller stuff. In Phoenix, the model is provided by another library called Ecto that can be used by any Phoenix app, or by any Elixir app. And you'll see a little bit later when we look at the Phoenix app, the way that Phoenix is designed is the view and the controller are actually in a separate complete application than the Ecto wrapper, which basically means that you can have other applications. It's sort of like, you can think about it as an API onto your database. You can have other applications that are not web apps that, again, would be running in Sidekick or Celery or something like that, interacting with your database at the same time as your web app. The final thing is, the two things. So then in the view, in Rails, it's ERV templates and action view, which are interpreted at runtime. Difference of that in Phoenix is they use a thing called embedded Elixir, which is available to anything. Anybody can use that, EX templates. Sort of like Golang templates, and they're not part of Phoenix. Anybody can use a template. The nice part about those are they are evaluated at compile time. So you can use macros. It does type checking. You can do type checking if you want. It does all the compile checks. So what it saves you if you've done big Rails apps is that whole worrying about, let me try to figure out tests to hit every one of my views and every possible, every possible code path of my views, is to make sure that, it gets rid of a lot of those kind of errors that you would have to test for in Rails. And finally, instead of kind of a monolithic controller, there's a combination of things in Phoenix, which may be a little confusing. There's a thing called plug, which is a specification and a library at the same time. That is kind of a pluggable, I guess what would in the Ruby world would be like rack, I guess. It's a way to kind of plug in the request cycle. And it works really well in that Elixir, there's a connection object that basically just passes through these plugs and sort of ends up, the last plug is the Phoenix controller itself as a plug. And that's where you do your business logic. Your plugs you may have in front of it may be like grabbing stuff from the session, doing CRSF token generation, that kind of stuff, and it passes to you. You can write your own plugs, and they're very simple to write. So things like your own custom authentication, any kind of things like that. So why should you care about it? I think that some of the things are it's built on top of, Beam and OTP. I talked about Beam a little bit, the VM. OTP is Erlang's open telecom platform, and it's really like a way to structure server-based apps. So it gives both a way to common kind of design pattern to build the apps, and also a set of supervisory structures. So in the end, what happens in any kind of Elixir app, you end up with a supervision tree. A very simple one could just be one process and it's not supervised. But most, even as simple as Phoenix app, is going to have a supervisor, and that supervisor is going to run the Phoenix app. So if the Phoenix app dies, it's going to be restarted. And you have a lot of control in that supervisor of how to restart and control things. So again, like under that Phoenix app, you could have another thing running, another app that could be going out periodically and pulling some API, filling in your database. You don't have to write that as something separate running somewhere else. The actor-based model, we talked about this a little bit before, naturally scales across multiple CPUs. The guy that wrote the Pickaxe book for Ruby, I forgot his, no, not Martin, Dave Thomas, yeah. Very excited about Elixir because basically the idea is we're getting more and more CPUs and more cores. So we can get a language that naturally scales to that, unlike most languages we have now, can take advantage of that. And I think finally, the functional design pattern, once you start learning that with a set of sort of library of high-ordered functions, it kind of changes the way you program a little bit. And it works really well with Phoenix and Elixir, and that if you can think of most web apps, all they are is transforming strings coming through, right? You get some input, you're changing it, outputting it. And that's maps perfectly to a functional style, right? So you're taking this data input, transforming it, and then outputting it. And finally, and I won't get into this at all, is it has metaprogramming built into it, which is macros. It's like Common Lisp has macros and stuff like that, which is a great idea for library authors to use. So the Ecto library has an entire macro system of doing queries. So if you ever used in the Microsoft universe link queries, it's kind of a high-level way to do SQL queries, or a way to rewrite them. Ecto has the same thing, has its own query syntax. Great for library writers. People say about metaprogramming is it's always great for someone else to use it. If you do need to use it, you can, and it's nice to write really concise DSLs or something like that for your problem domain. But the problem with that is people have to understand the macros to get to it. So usually a good idea to start with the function, and then if that function if there's a reason you need to transform the code during compile time, turn it into a macro. Otherwise, leave it as a function. And like if you're used to macros in like C or something like that, this is not a macro across the string of the code. It's actually the macro runs after, just like in Lisp, it runs after it's processed the tree. So you can, just like in Lisp, you can rewrite code. So Elixir code can rewrite itself. And that's what it's doing, like in those the Ecto queries. It's actually generating code for you. All right, so in Phoenix, care about that. Most popular framework. Again, for MVC framework, you don't have to use it. You can drop down to write your own plug, is like writing your own rack thing. You can kind of go down if you don't need the whole model and view and stuff. If you're just doing a very simple HTTP server, you can leave it behind. But if you're using anything, if you care about things like you care in Rails with migrations and views, and instead of having to figure all that stuff yourself, you can use Phoenix, and then someone else can pick up your code and understand it without having to do that to kind of dive in. And if you do have a Rails or Django experience, it's going to be pretty natural with the kind of the layout. And unlike Rails or Django, it's crazy fast. And this is like microsecond delivery time of stuff. Yeah, not millisecond, microsecond delivery time. And so when you're doing development, running tests are going to be instant. Unlike sometimes legacy Rails app taking 30, 40 minutes to run tests. And just like Rails or Django apps, you don't need these set of external processes running to do things like delay jobs or having to use shared object storage, like Redis, or something like that, or Memcache or something like that, with a built-in node being available node-wide without having to worry about it. You can run your object storage on a completely different server and it looks local. You don't have to worry about that. And the Beam ecosystem automatically, you bring something up. All you have to do, they call it a cookie, which is a horrible word, but because it's older than the web and they've used it since the 80s. All you have to do is a secret to join a node. And once you're in, they have their own consensus algorithm that's been around for years that sort of makes everybody aware of everybody in the node. As soon as you join one, as soon as one node in the cluster knows about a new node, everybody else will quickly learn about them. And you can call functions across the nodes by name or by process ID. All right, so I think we're in good time here. So I'm just going to do an example Phoenix app. And this is, again, if you go to Phoenix Framework, you can look at this. It's the Hello World app. Just giving some quick prereqs. To be able to do this, there's sort of a set of things to get it running. The first is installing, and this will run on Mac, Linux, PC. I was, up until recently, actually using a VM to do this in, and I've just moved it over directly into my Windows machine. The only change I had to make on the app that I was working on is I had to change out one library because it was not building correctly. It was using a little bit of this. Erlang has this idea of ports where you can actually write something in a separate language and it communicates between there. So they had written part of this as a port in C, and they had used a version of GCC liked it, but Visual C++ did not like it, so it wouldn't build. I ended up having to use a different library that did the same thing. It was for hashing passwords, basically. It was trying to use, doesn't matter. So after you get Erlang on, which lets you use the Beam, which you're not really going to use, you're not going to interact with that yourself at all. But then you install Elixir, which then uses Beam to run. So it gets you the Elixir compiler, and also along with the compiler, it has a interactive IEX, interactive session REPL. And it also includes this program called Mix, which is, best I can come up with the name of this, it's a Swiss Army knife. It's like a build tool plus a dependency tool plus everything. So you can write these mixed tasks that are local or import other people's mixed tasks, because part of Mix, the core part of it is dependency system. You can pull in someone else's dependency and now you get more mixed tasks. So your local tasks, it's sort of like using NPM, but instead of NPM just being the dependency thing, imagine it's NPM scripts along with NPM at the same time. Again, it's like a kind of a Swiss Army knife. Once you have Hex installed, you install Mix, you install Hex, which is a package manager. So Mix just does dependencies. You have to tell it where to go. Hex is sort of just like the NPM registry. People can host there. It does some really nice stuff, and that there is, inside of Elixir, there's a standard documentation, docstring format, and it extracts all that and generates really nice documentation for you. And then finally, via Mix, you install Phoenix, which is just another dependency in your Elixir Mix for the whole application. And finally, you can get Node installed. Phoenix, which I don't know why they picked this. They use Brunch as the front end. You can replace that with Webpack pretty easily if you want, which I would recommend if you actually did this, because the app I've been working on, I didn't give you a little background. So I've been using Elixir, playing around for a couple of years, and then about 3 months ago, I started working on an app for a client that's going to go alpha or go beta this week, which is a ticket management system. I was talking to Trevor. The reason I picked it is I've been looking for an app to do Elixir in. And then I had presented to do this app, which I didn't want to do because I've done that same app 50 times. But then I was like, if I do an Elixir, I'll learn that. And it's actually worked pretty well because it's a ticketing event app that basically gets a thundering herd of people. So I was thinking Elixir would be a good use for that. Or sorry, Phoenix would be a good use for that. So this is basically taken directly from the Hello World stuff. I'll just run through this. And stop me at any time if you have questions about the syntax stuff. I'll probably go into the syntax a little bit. And the idea for this, again, is to show you sort of how the tools work, how to set it up, give you a little bit of a flavor of what the Elixir syntax is. This is pretty simple. There'll be no pipeline stuff in here, no process stuff, but it'll just give you an idea of sort of the look and the feel of an Elixir app. So once you install Phoenix, it actually creates these some new tasks for you. It used to be called Phoenix. In 1.3, they redid a bunch of stuff, and he actually renamed the tasks because in 1.3, Chris McCord kind of redesigned Phoenix. So instead of just being a web app, it became an umbrella Elixir app, which gives us the idea about being able to run other servers at the same time. Before, everything, like 1.3, you really think at the high level, it pulled the model out of the web part and stuck it in a different app. And so they just decided just to rename the tasks so that you could run them in parallel. So this is sort of like Rails generators. So you run this mix task, you give it the name of the app. It's going to generate a bunch of stuff. It's probably hard to see it in Elixir. It's going to generate a ton of files. It's going to ask you to install the dependencies. And then these dependencies are done again through a mix task. And this kind of thing you'll be using outside if you ever use a standard Elixir app. Again, deps is sort of the core of mix dependency stuff. So it's going to grab all the dependencies, it pulls them from GitHub, or it can pull them from other places. Then it compiles the dependencies. And unlike, we'll see it in a couple more slides in the structure of the folder layout. There is a deps folder. So it's kind of like the node modules folder, but it will have the compiled versions of those. It has the source code and the compiled versions. So it makes subsequent compiles much faster. It's not compiling your whole, like in Node, it's not going to go through all the requires and you have to pull all that in. It only does it one time when you compile. And the final step is if you do you elect to do branch, which is the default, you can turn it off when you create one. It'll go in the assets folder, which is sort of where everything, all your JavaScript and CSS and stuff goes there. Runs Node, runs npm install, and starts running branch. So at that point, again, this is all the output from Mix, the PHX new. It's telling you what to do next. So create this hello subdirectory because that was the name of your app. So the first thing you want to do is run ecto create. Can everybody see that, or should I make that a little bigger? Bigger? No. Okay. And what that does is it says then you configure your database. That's the tricky one. There is an Elixir file you have to go into in the config area, and basically you point to your database. It's like the Rails database YAML file. You're basically pointing to where you want it at. And like Rails, there are by default development test and prod. And the config files are all there. And then what's nice is they bake in this _prov folder, which the prod runs, and then it includes everything in prov. And then by default, when this creates, it actually puts prov in the git ignore file. So make sure you don't shoot yourself in the foot. So you put all your secrets, you can put them in the prov folder if you want, and they won't be put in GitHub or anything like that. That being said, you can use a standard function inside that config to actually pull the value from an environment variable. So if you're doing it on Heroku or something, you have to specify the environment variables. You can just pull it in. So in the config file, instead of setting it, call this function that looks at the environment variable to set the value. So finally, after you do that, you run ecto create, which creates the database. At this point, we really don't have a schema or anything, so it's not going to create any tables. And then you start the server, and there's two ways to do it. One is you run it directly as a mix task, and that's just going to run in the console. I'm going to show log output. The other one is you run it interactive. And what this says is, before running PHX server, look at this, load the mix module, and we'll see in the code there's a mix.ex folder, and that sort of does all the magic of hooking everything up for you. So that runs, so it's just like you're running PHX server, but you're running inside IEX. What's nice about that is you can run it, running it just like we saw in the closure script. You're in a REPL now. You can be changing things while the server's running and looking at things. So finally, we're just going to run it this way, PHX server. So it's going to come up, and I just wanted to show you this to show kind of what it's doing. So the idea for Phoenix, it finds an endpoint, and that endpoint has a port, basically a TCP port, and it's using the Cowboy web server, which is a Erlang-based web server. It's been around for a long time. Again, so what Phoenix was designed for is it's trying to pull together a bunch of common, well-used modules into one kind of known built stuff. Parts of 4000 interfaces. And then it's going to show the logs. So the first one, it actually goes and compiles everything. So it compiles 6 source files into 2 Beam files, into 2 VM files. Those Beam files are bytecode, but with 2 releases ago, Beam has pulled in basically the same thing as Hotspot has in JVM. So the Beam will load in the bytecode, but then it will turn that back into machine code. So it's not interpreting the VM bytecode anymore. It's actually compiling that as soon as it's loaded in the VM. And then the copied one is for anything in your assets that Brunch did. And it's set up just like if you Webpack and watch or whatever. It'll watch your assets folder and invoke Brunch for you and restart everything. So when you run it just like in the Rails Hello World app, you get this, which by default has the Bootstrap framework in there. So the structure of the app coming up is, we'll go over this pretty quickly. This underscore build is sort of the build byproducts. You never interact with that. Assets are where your JavaScript and all that, the non-Elixir stuff are. Configure files, the priv folder is under that, or no, sorry, priv is there. Gaps are everything you download and compile. And then lib is sort of where your code lives. So if you ever go on GitHub and look at any kind of Elixir app, the first thing you probably do is just jump to the lib directory. That's where the code is. Everything else is sort of support files. And the lib folder is basically pulled into 2 applications. You have the Hello application and the Hello web application. So this is what is shown in the website, and this Hello app is, I shouldn't say application, but I guess application. In the Erlang world, you think of an application, or in the non-Erlang world, you think of an application as the whole thing, right? In the Erlang world, an application is just a program that runs in the VM. And you can have multiple applications running concurrently in the same VM talking to each other. And they just use the term umbrella application to have more than one. And then these 2 are sort of the endpoints. That I said it loaded this web endpoint there. And then these are where your secrets are, and then that's the standard, just like Rails, a test directory. And it generates a bunch of tests for you, test framework for you. So if you jump into this part, into that directory. Again, just want to show this real quick. Phoenix, by default, supports WebSockets and channels, all baked in, which is really nice. And it's very simple to set that up. So if you want to have, browsers talking to each other, chat applications, that stuff is baked in. The rest of the stuff, as you see, we have the sort of the V and the C part, and model parts in that other application. We have the sort of the main controller for the site. Layouts, and this is just like in Rails, it's sort of the outer framework that your page is being rendered within. The template for that endpoint, and then these views, which is a little bit strange. And I'm not quite, I don't think I quite understand why they have separate, they say they have separate views, each controller. And the idea of views is you can specify methods inside the view, and they'll be immediately available in the templates. But I ended up doing just making a shared view that everybody loads through their, I actually updated a tiny bit of their the macro that gets loaded, so that otherwise you have to kind of replicate functions around. I'm sure there's a reason they did it that way, but again, this is sort of the context and where the template runs. And finally is a router, which we're going to look at, and I think we have time for it. So we're going to go real quick and add a new route. So we'll sort of skip through some of this stuff. Use real quick, that loads a module in, but loads it and tells it to run the macros across here. So when this use comes in, it says make this whole module a router. There's a lot of magic that happens. And that actually creates some of these functions here called pipeline and scope. And And here we're defining a pipeline browser. So, and we'll show it where it pipes through here. And this is kind of the pluggable interface. So you kind of think of it this way: is when I go with anything within Slash, it's going to be the Hello World web app. Pipe it through this pipeline browser, which then puts it through these plugs. And there were multiple other plugs I took out, so it stays within this screen here. It just tells like that's the accept header, tells the fetch session, you can do anything like that. This is a separate pipeline, and I did this a little bit. I actually compressed this a little bit. This is a different way to show Elixir syntax. This is actually what this do end here is actually a macro that's compiled down to this, which is a keyword extension. Again, we won't get too much into the Elixir stuff, but that's a different pipeline. So for anything in here, we're going to pipe through the browser. For this endpoint root page, we're going to go to this method on the page controller. And then adding a new route to those existing, we're going to add in this new hello route. So inside the controller, I think I copied the wrong one in. Oh, we did. Imagine there's a hello method here. Basically make it the same thing, right? So it gets past a connection, which is this thing that gets passed down to the plugs. You can alter a set of parameters. We set with underscore in front of Elixir because we're not using that parameter, and Elixir will not compile if you don't use a variable. Considered an error if you define a variable that's not being used. You do set the underscore in front of it, it's an ignored variable. So this is basically calling the render function. And like Ruby, you can omit parentheses if you want to make it kind of look cool in DSL and stuff. I don't know. It works well, like for the Ecto queries and stuff. I think for this, I think they probably should. I think the newer compiler actually tells you in certain things that you should not do that to make it clearer. So this basically calls the render method. Again, this use one tells Hello Web to run the controller macros on this module on everything else, which defines these render functions and all that stuff. So it tells render to do this template. And then the template itself, we'll skip the view, another module that tells this Hello Web to run the same thing, but make this a view module in the macro. And then the final template's just HTML. We don't have any variables in there right now. And that would be the result of that. So if you're still interested, there's some resources here. Elixir has its own site, Elixir Lang. Phoenix has their own. There's my slides. And the pragmatic bookshelf, like I was saying, Dave Thomas, he is a huge fan of Elixir. And as you can see, they actually have a large, they're actually just coming up with a newest one. I wish they had it for Rails. It's called Implementing Elixir, Introducing and Implementing Elixir to Your Team or something like that. It's a way like a way to convince people to use it and how to use it. Not convince them, but sort of how you'd use it within a team structure. So that's it. It's 11:45. Guys have any questions? Let me turn this just real quick. Let me turn the thing off because every time I watch a conference and there's a Q&A, it's just like silence for 2 minutes and then the person answers. You have no idea what they're saying. All right, let me turn this off.